Okay, so a redox titration calculation. Now really, these have got the same 3 steps as any other calculation based on equation that we've done at higher. So we've got our step 1, which is the tick mole, step 2, mole to mole ratio, and step 3, question mark, what we're calculating. So if we go through the straightforward version of calculating concentration, which is typically your 3-step here. So I'm going to do the same as I've done before. I'm going to look for my tick and my question mark information. So I'm being asked to calculate the concentration of hydrogen peroxide. I'm now looking for other information about hydrogen peroxide. So number 1, there it is in the balanced equation. And number 2, they tell me I've got a 25 cubic centimetre volume of hydrogen peroxide. The other piece of information I'm now looking for is what reactant do I have the information about. So I've got a volume and a concentration here of permanganate solution. So my permanganate solution, again, here in my mole to mole ratio. So as normal, I will narrow my focus down. So I've got my 2 permanganate ions and they're reacting with my 5 hydrogen peroxide. So I have a question mark here and a tick. So same as my start would be for my other calculations, and I'm now going to get to my simplest mole to mole ratio. So I've got 2 mole to 5 mole, but I'm going to take my tick side to 1 just to give me the simplest ratio possible here. So to 2.5. So I've got a 1 to 2.5 ratio. Step number 1. Step number 1 is my tick mole. So I look at the question, and I'm trying to calculate number of moles. The information I'm given is of concentration and volume. So I'm going to use N equals C times V here in terms of the triangle. Remember, volume must always be in litres, so I'm going to divide that by 1,000. So my concentration is 0.1 and my volume is 0.016. So therefore I've got 0.0016 moles. So I know how many moles of my tick I have. Step 1 complete. Step 2, I now want to use what I've calculated here, take it up to a mole to mole ratio to find out how many moles of the question mark I would require to work with this. So I now take up for step number 2 and do my mole ratio. So I've now got 0.0016 moles, and if I look at my ratio, it's a 1 to 2.5. So I simply multiply by 2.5 here. And if I multiply by 2.5, I get an answer of 0.004. So that's how many moles of the question mark side I have. But I'm not being asked how many moles of hydrogen peroxide I have. I'm being asked for a concentration. So again, concentration, therefore I'm using my NCV triangle, number of moles over volume. My number of moles, this is where I've carried out my whole process here, and my volume, again 25, but we know that volume has to be in litres, so again I'm going to divide by 1,000. So divided by 0.025. So my answer, 0.16. Now it doesn't tell me the units, therefore I need to put my units for concentration in, so mole, litre, minus 1. Okay, so redox titration calculation in its simplest form here when we're calculating concentration, 3-step process, tick number of moles, take it back up to the mole to mole ratio to find your number of moles of your question mark, and then turn that number of moles of question mark at step 3 into whatever you've been asked to calculate. In this example, it was concentration. Now, the next example I'm going to give you becomes a wee bit more complicated. And the reason for this being, sometimes when you do a redox titration, for example, it could be a vitamin C tablet, and you dissolve your vitamin C tablet in a 500 cubic centimetre standard flask. But you're not going to stand and titrate a whole 500 cubic centimetres. You're going to do a sample of that. So your calculation is based on the sample that you take from the 500. So say I took a sample of 25 cubic centimetres from my big flask. I would then have to, if I want to find out the mass of vitamin C in the whole tablet, I would have to scale my answer from 25 cubic centimetres up to 500. So when we're being asked about a mass, we tend to have to put a scaling bit in. So I usually scale it between steps 2 and 3. So I'll take you through the process, same again, let's do the same. So let's highlight our ticks and our question mark. So I'm being asked to calculate the mass of hydrogen peroxide in 500 cubic centimetres. But what you'll notice is when I'm looking at other information about hydrogen peroxide, I've got it there, but I've got a 50 cubic centimetre sample. So straight away, I'm looking at this and thinking, right, okay, I've got a problem here. I'm looking at 50 cubic centimetre samples, but they want to know about how much hydrogen peroxide was in the whole solution. So I'm going to have to scale at some points. So I need to remember to scale. So when you're doing a question like this, and you notice that you've got your 2 volumes, you're going to have to scale. And then I'm looking at my permanganate. I've got 32 cubic centimetres. I've got 0.2 mole per litre of permanganate solution. So again, I'm going to narrow my focus down. So I've got my 2MnO4 minus. I've got my 5H2O2. So I've got a 2 mole to 5 mole ratio. I've got my tick up here and I've got my question mark here. So again, I'm looking at my information. I'm also looking now and seeing, right, I can simplify this ratio to the tick side more. I can take it to my 1 to 2.5 mole. So for every 1 mole of this, I have 2.5 times the number of moles for hydrogen peroxide. So here we go again. Step number 1 is my tick mole, so number of moles. Look at the information I have, again, a concentration and volume, for which my volume I'm going to divide by 1,000. So N equals C times V, concentration 0.2, volume 32, but I have to divide it by 1,000, so 0.032. So my answer is 6.4 times 10 to the minus 3 moles. So that's how many moles I have in my tick. I'm now going to do my step 2 and take it up to my mole to mole ratio. So step 2 is my mole ratio. And at this point, I'm going to take my 6.4 times 10 to the minus 3 and drop it in. I've got a 1 to 2.5, therefore I'm having to multiply by 2.5. Okay? So if I multiply by 2.5, I've now got 0.016 moles. Now at this point, I would normally now go and find out the mass, and I would find out my mass, my question mark is mass, I'd find out the mass in that sample that I've completed. My mass is 50 cubic centimetres. Now, I can, at this moment in time, I can work out my mass, or I can scale my moles and then work out my mass. So it's really up to you what you want to do. So what I'll do first is I'll complete the process and then we'll scale. So if I now go to number 3, which is my question mark, I'm working out my mass, and mass is N times GFM. H2O2 has got 34 grams GFM. So I've got a number of moles of 0.016 and my GFM is 34. So I've got 0.544 grams. But this is the number of grams in the 50 cubic centimetre sample. So at this point, I suppose I'm going to scale now and say that 50 cubic centimetres contains 0.544 grams. So what does 500 cubic centimetres contain? I've multiplied by 10, so I'm going to multiply by 10. And my answer becomes 5.44 grams. Now what I'm going to do here is I'm now going to do the same thing, but I'm going to come down the middle here and show you that it doesn't matter where you scale, you should still get the same answer. So what I could do is, in here, before I go to step 3, I could do my scaling here, right? So I've done my scaling at the end here, but I'm going to do my scaling at this point here. So I can say that if I've got 50 cubic centimetres, then I have 0.016 moles. But if I had 500 cubic centimetres, again, I'm multiplying by 10, out of 0.16 moles. And then the last thing I do is then do my step 3, which is my question mark. And I can say, step 3 question mark, mass equals N times GFM. My number of moles I've said is 0.16 because I've scaled to how many moles are in 500 cubic centimetres, times with my 34, and my answer is 5.44 grams. So you see there that in this process, the scaling bit becomes obvious because you can see, okay, right, I've titrated a sample of 50, but they're asking me about the whole solution. So you make the decision as to whether you want to go through your normal 1, 2, 3 step process and then scale at the end. So you find the mass within the sample that you've got and scale your mass to the whole solution. Or before you finalise your step 3, you can scale your number of moles and then turn that into a mass. Either way, you'll get the same answer. So redox titrations, step 3, 3-step higher calculation, 1 tick moles, 2 mole ratio, 3 question mark. But be careful with mass questions because there's a point where you would have to scale if you've only titrated for a sample, but the question asks you for the whole solution that was made up.